Hello, welcome back to another video on YAGSL. This is going to be part 3 of this series, and we're going to be talking about simulations today. If you haven't watched the last video, I recommend you do, as we're basically going through how to program or make your first program, and you should have all this code that you see here. So how do we start with getting our simulation? Well, first thing first, I recommend always just pulling up the documentation on the side, just so you can follow along as they explain things a bit more, or they explain things in more detail, I guess, yeah. And so, follow along with the documentation. They probably add more things about stuff that I don't talk about, but first thing they say here is going to be, enabling desktop support. So when you're making a project, usually you probably ignore this check mark. And so if you haven't have that enabled, we can go to our little icon here and we can type change desktop support enable settings. And it's going to give you a little pop-up that says, do you want to enable support for project? And so if you have this at false, switch it to true. Although I'm pretty sure with this tutorial, you don't actually need this setting to be on, but the documentation recommends it anyways, so I'm going to enable it true for now. Although I'm pretty sure everything does work if you do have it off. So what's next? Okay, so first we are... Okay. So we're on the next page here, and they're going to tell you how to simulate the robot's code. So we have our code here, and now we're going to go to our little icon, and we're going to type simulate robot code. This is a built-in feature with WIP lid, and what they're doing is they're going to build everything, and it might take a while if this is your first time, and basically they're going to ask you what extension to run. We're going to pick sim GUI and press OK. So it's going to run again, might take a while, don't worry. And we're going to see this pretty messy screen. Don't worry, don't get too overwhelmed, I will show you everything. First things first, I gotta thank my sources, as once again, documentation will tell you where everything is. So docs.wip lid.org. So this basically tells you where everything is, but I'll give you a quick rundown on what I think is important. So here, this is your robot state. This is pretty important as you can change between disconnected, autonomous, teleop, and this is pretty crucial as sometimes you are just, trying to add inputs and you're figuring out and you're wondering why isn't our robot moving? Probably because you didn't turn it on. And with a simulation, that's even harder to tell, so make sure when we get our inputs all set up, make sure you press this teleop button later. Down here, this is our FMS. This is basically our field setup. So you can say if it's during autonomous or teleop, and if what alliance number or what side of the alliance you're on. So this is useful if you're trying to adjust your autos for a certain spot. This timer here is for things that require timers. So if you have that, that's good. System joysticks here, this one's pretty important. This is basically what kind of inputs you're allowed to have, or are currently available for you. So if you have two controllers plugged in, you're gonna see something here. However, since I have no controllers with me, I'm gonna be showing you how to use simulations using your keyboard. Here, this is just network stuff. We're gonna go down to joysticks here, as this here is gonna basically assign or basically tell you how or where you're gonna see your joystick inputs, right? And so I'm gonna start by basically adding my driver input, since all I have is a source drive in my code. That's all I need is one controller. So my first joystick is going to be keyboard 0, as I'm using a keyboard. So now you're going to see like 3 axes here and some POVs. How we basically change the settings for this to work is that we're going to go to our DS and we're going to click on keyboard 0 settings. So these axes basically represent our like joystick on a controller. So this here I'm going to add 5 more, and I'm pretty sure that's good. Okay, okay, so you can click on these to change your keyboard or like what keybind you want them. So if you find it kind of wonky and you for some reason really love the keyboard or like the hand layout of RGFD, then go ahead. This is how you would change it, but I'm personally a WASD fan. And yeah. So this is basically how you represent your axes. You can add more or less. I'm just going to do the same amount as what the example code has shown, as I don't want to tinker with that too much. And that should be good. So now we have our joystick layout or figured out. Let's go run something. If you notice, even though it says is a simulation, there is a lack of simulation on the screen. Even if we press teleoperate, you don't see anything. Why? Because we haven't have our field out yet. So how do we do this? Now you see these on the top, these buttons on top. We're going to disconnect first. We're going to click on network tables, and then you're going to go to smart dashboard, and you see here, there is one called field. Check that on, and mine is right here, currently invisible. I'm going to click on that arrow, and what you should see is the screen. Congratulations, you have your field. And so the rest is self-explanatory, as we're going to press teleoperate and move your robot. And if you notice, your robot moves. This is great. Although it's a bit slow, don't worry about that. On one more thing, if you're happy with just this turning, then go ahead. I don't know if it actually works with a joystick or not, as I haven't tested that, but I'm pretty sure it would. Although one thing that I have noticed is that we have these controls here, right, would be on your left stick. However, if we remember from our DS settings before, we had ER and LK to represent our our right joystick. The problem is it doesn't seem our robot can turn. We can move up, down, left, right, although the controls are slightly inverted as it's to represent what side or what alliance you're on. But we can't turn our robot. And so if you see down here, I'm changing my axis here, but our robot isn't moving. But when I click on my WASD buttons, we can move them. So having just a fixed robot on the screen, or fixed robot, isn't exactly great. And so how we're going to fix this is that it's actually not a problem with the code, rather it's how they calculate it slightly differently on the robot simulation, and we need to basically make changes to our code to adjust for having a simulation. So we're going to X this out for now, and I'm going to pull up to our code setup and on docs.YAGSL.com, and we are going to go basically to, let's see, where is it? Here. The example, we're going to open this in a new tab, and let's go to our robot container. And so, Okay, that's the example code. Whoopsies. So here's our project, and we have our input stream for angular velocity. What we're about to do is basically create this kind of again, but for simulators. And so we're going to go to our robot container in our example code. Scroll down. So here's line 59. This is basically what we did in the last video. We took all this code and we made it into our project. And then if you scroll down, you kind of see the exact same input streams down here. But if you notice at the top, at the end, it says drive angular velocity sim. Oh, isn't that fun? So this here is for, of course, if you can't guess, is your simulators. So we are going to basically just copy paste this and put it in our code, as even I don't know all this voodoo magic. And I'm going to try to keep this tutorial pretty simple, as technically it does work, but this is for if you want your turning to work. So I'm going to give some divider here. So basically, if you didn't follow along, I copied from 91 to 111. Actually, no, you don't need this code. Yeah, you don't need set point. So I'm gonna get rid of this in our code right here, as we don't have path planner. Awesome. So once again, there is a bunch of errors in our code, and these errors here, these two, are basically saying that there's errors inside the error, where like there's errors here, and that's why this is not working. And to get this working, we are going to rename these driver X boxes, because oopsies. So what they're complaining about is that up here we made our controllers called mDriver controllers, and in our example code that we just borrowed a bunch of code from, they called it Xbox driver Xbox. So what I'm gonna do is just copy this, and then I'm gonna press Control F, and then this drop down here, put driver Xbox, and then I'm gonna paste in mDriver controller, and then I'm gonna replace. See all these, and then we're gonna replace all, and ta-da! Everything is gone. And this here is basically the exact same thing from up here. It's just taking the inputs from our controllers. Left, you see here's our deadband, and like right here, it takes the inputs from our controllers, and it basically so it takes our left Y and then our left X, and then it takes the axis. So here's the second axis. So I guess you only need technically 3 axes. Okay, that makes sense. So yeah, so remember the turning was a problem, and that was from our axis 2. So here is the code where they're calculating the heading or the angle of where to turn right here. So here's how we fixed our problem. And then they create a man called drive field oriented angle sim. And here they called the method that we made in the last video in our subsystem. And okay, so this is where they get the velocity from. So this is how they got the velocity, and this is how they know how to turn, or the heading of the velocity. And if you ran this code right now in our simulation, one thing you've noticed is that it still doesn't work. Why? It's because we haven't created our default command yet. And so if you notice up here, it says set default command angular velocity. Right now, we want to turn this into, we want to check if it's a simulation first, because if it's a simulation, then we want to use our command down here that is for our simulation, right? But we don't use keyboard layouts on the actual field or in the game, and so when we're actually like testing it in the real world, we rather use our joysticks. So we need to make sure we find a way to check whether we're in a simulator or we're not in a simulator. And what we can do is we can do that. We can basically write that out. And if you're lazy, examples right here, but I'm going to type this out as they're copy and pasting it won't actually like get this to work the first time. So, all right. So we're going to say when it's not robot base, when robot base is in a simulation, we are going to, this is what it is, and then if it's not, then we're going to keep this as true, and then when it's false, we're going to drive field oriented angle sim. So, okay, what did I just do? This is shorthand for an if statement, and basically a nice acronym to remember. What's happening here is WTF. So this is, W stands for what, so this is what it's checking. If the robot is not in a simulation, if the robot's not in the simulation, if that's true, then we're going to use our drive field oriented angular velocity command, and that's for when it's not in the simulation. And then if the robot is in a simulation, then this is going to output as false. And so if it's false, then we're going to use our simulated command. And what that does now is that we should have a working robot in our simulator that can turn, move, and do basically everything a drive should. So I just press simulate robot code. Now it's executing all this. It's going to take a bit. I'm going to pick sim GUI. And then I have our field here. I'm going to press teleoperate. And one thing you notice is that it turns. First thing it does is turns, and that's probably a good thing. So now if we notice things look jank, so everything moves as normal. But if we click on E and R, we rotate. Now isn't that fun? So we can rotate counterclockwise, clockwise. We can move while rotating, and it's basically a simulation of a drivetrain or a swift drive. Okay, so you learned how to make your robot move in a simulation, but look at this absurdity of a box. The boxes overlapping each other. It's just a bunch of red, ugly, green Christmas colors. Like, what is this deformed Grinch? And you're like, how do I change this to make this look nice and aesthetically pleasing? Well, there's a little secret here that resides in the little burger. And you're going to see this little field. And we are going to go to our X modules here, and we are going to change them so they are less absurdly massive. So we're going to check off the hidden, and then we are going to make this so this is maybe like a blue color. Yeah, I like that. Make it a dark blue, and I like that. Yeah, we're just going to change these till it fits our robot. We can change our arrow sizes. I'm going to make this slightly smaller. And let's see. Width, length. That's good for now. Odometry. I'm going to make this a different color completely.
Hi, I'm not playing with you.
And now we have our robot. Wow, it does not like our odometry. But now you should be able to see everything running correctly. And this is how you make your robot nice aesthetic. One thing you can do about the field is that it's kind of small. What you can do is just enlarge it. You know, that arrow is kind of small though. Ooh, these inverted controls, not used to them. Yeah, so you see this pink box here is for your odometry. Currently, I have not messed with any of that, so it's as off-centered as it wants to be. This is going to be our robot the simulated robot position. This is our odometry position. So the color shows. I'm going to make this arrow quite much bigger. Apparently you can put images on here. Well, that's fun. But yeah, this is how you make this nicer looking to look at. There's a bunch of different settings to play around with. And yeah, I'm going to leave it to that. So this is going to be the end of the tutorial for how to basically open up your simulation and add your settings as well as run your robot code onto here using YAGSL. I hope you appreciate this tutorial and happy swerving!